Welcome to Maheepathi Talks. Because of this COVID-19, school stopped working, colleges stopped working, but learning never stopped. And sharing of knowledge has not been stopped. Eminent personalities like Dr. Anuradha ma'am, they have come forward to share their knowledge. Today, the important topic that ma'am is going to share is machine learning, a friendly approach, which is very important for any person. Today, the buzzword is machine learning, artificial intelligence. I'm happy that ma'am has accepted to deliver the talk on machine learning, a friendly approach. It's my privilege to introduce Dr. K.Anuradha ma'am. She's an assistant professor working with the Department of Computer Applications, Karpagam Academy of Higher Education, Coimbatore. She's got more than 1.5 decades of teaching experience and 1 year of industrial experience. She has finished her PhD, MA, MCA. She got many awards. Best Project Award UG instituted by PSG Tech Alumni Association in 2000. Best Faculty Award 2015-16 by Karpagam College Engineering. Favorite Teacher Award by 2017 voted by MCA students. She has delivered number of guest lectures. She has got many publications in national and international journals and magazines. Ma'am has filed for the patents in the September of this month, and she has got 25 plus publications. It's our privilege to invite ma'am, Dr. K.Anuradha ma'am, to deliver the talk on machine learning, a friendly approach. We welcome you, ma'am.
Thank you, sir. First of all, I thank Dr. Srinivasa Rao for inviting me this Maheepathi Talks. A warm good evening to all. Can I share my presentation, sir?
You can, ma'am, please.
Okay, thank you. Good evening, all. We can make the machines as our friends. That is topic machine approach. So we know machines are learning. We can make the machines learn. We humans learn from the past experience. So likewise, we can make the machines also to learn from the past experiences. So what is machine learning? So we can say machine learning is a subfield of computer science. So we know humans learn from the past experiences and machines follow instructions given by the humans. But what can we make the machines to learn? How can we make the machines to learn? How can we make the machines a user-friendly approach? How can we make the machines a friendly one? So nowadays, we know washing machines are friendly to ladies, and likewise, all other machines, we have made them as friends. So likewise, machine is always learning. Okay, as humans, machines is always learning. So, but what if humans can train the machines to learn from the past data, and what humans can do faster? So that is the thing we are going to see now. So it is all about understanding and reasoning. So like human brain, we can make the machines to understand and learn, understand and reason. So the machines can decide either this or that. We have to make the machines to decide either this or that. Now, many organizations are looking at how they can adopt machine learning for their research and analysis. Now, we shall see the proper definitions for it. So, it was coined by Tom Mitchell in 1997. So, here it is set to learn from experience with respect to some class of tasks and a performance measure P. If the performance at tasks in the class as measured by P improves with experience. So there are three things to be identified. So the first thing is we have to define learning with respect to a specific class of tasks. either diagnosing diseases or writing examinations by the students. So like this we can make it. So if we think examination by students, so there is an evaluation criteria and there is a result criteria. So we have to make the machines to work in that way. So but we have to be careful about defining a set of tasks. So what the set of tasks are going to be. The second thing is we need the kind of performance measures P. So in the absence of any performance measure P, you could start a weak statement like, okay, I think something might be happening. So like this one. So to know whether learning is happening or not, we have to make some criteria is there or not. Okay, like examinations. So the performance writing examinations is the performance. Okay, then evaluation. So correcting the answer script is the evaluation. So like this we could make the thing. Then the second thing is, and the third important thing here is the experience. So this comes for the machine learning. So the experience, the performance has to be improved. Okay, in case of experience, the experience could be writing more examinations. So if the student writes more examinations, then he could get a better mark. Okay, so these are the three things we needed. One is the set of class, that is the class of tasks. Second one is the performance, and the third one is the experience. So these are the things. Okay, now the next one is, here we are seeing a model. So in this model, we are providing an input data. So that input data is being fed into the machine learning algorithm. Now, that machine learning algorithm will divide what type of data it is and how to be identified. So we are seeing a model here. The input data is fed to the machine learning algorithm, which is being designed by us. Then depending on the data, the prediction is made. So when you clearly look into this slide, we can understand it. So if we get a good result, it is okay. Yes, if we are not getting the good results, then we have to design the model again. So that model has to be well designed. So once the mistake is being taken, once the mistake is being started by the model, then from the mistakes, the machine has to be remodeled again. Now, let's go into the second slide. So here, the thing is, what do you mean by apple? So now everything can remember, what do you mean by an apple? So we know it, an apple is a fruit. Okay, normally a normal person can identify an apple as a fruit. But now, so if it is of this type, okay, so here we are seeing three pictures. So the participants can give three different meanings here, or many meanings if they understand what is an apple. So a red apple, an apple logo, and a green apple. Maybe some other type of apple, a cherry red apple, or any other apple maybe. But from these, the features are different here. So the red apple, the color is red. And the second one, the apple logo, so it is not a real apple, it is a design logo, its feature is a design logo. And the third one is a green apple, so its feature is its feature color is green. Okay, so now the features are different here, but the label is apple. Okay, so from this we can identify the label of these three images is an apple, but the features are different here. Okay, so now we have to identify these features, and from these features we can predict which is a real apple. Okay, if we want to segregate apple, pure apple without any impurities or something, we can segregate like that. So if we want to identify only a green apple, then we could classify. So all these we can measure. And here we can see uh, the training and the testing phases, prediction and everything. So we are providing a set of features here. From that features, we can make the machine to predict what type of apple it is. So the apple is the label. From that, we can make the machine to predict whether it is an apple and what type of category it belongs to, whether it is a rotten apple or some other case. So that we can classify it later. Then, what is the types of machine learning? What are the types of machine learning? So we could broadly classify into three types. One is supervised learning, unsupervised learning, and reinforcement learning. So these are the major classifications of the machine learning. So we can broadly classify into three. And there are generally three. Supervised learning, which we can say it is task driven. And the next one, and here we are seeing two images. So the first one is the supervised learning and the second one is the unsupervised learning. So the first, it is a model built by providing a data set with concrete example. That is, this is a duck and this is not a duck. So we are giving some duck images and we are making the machines to identify whether it is a duck or it is not a duck. And in the second approach, it is an unlearned one. It is an unsupervised learning. So it is used to discover some structure within the given data. Okay. So the initial data, it may not be necessarily labeled. Okay. But in the supervised learning, it is labeled as duck and we are making the machine to identify whether it is a duck and whether it is a not duck. And in unsupervised learning, the initial data, the label is not known here. And the learning uses clusters. If you are giving some set of images, it builds a cluster first and then it tries to identify, it tries to classify from that one. And what is supervised learning? That is a machine learning task of learning. Suppose there is again the thing here, we are seeing three different coins of three countries. One is rupee, euro, and dinar. Then the weights of these three coins are different here. For example, for a rupee, approximately it weighs 3 grams, and dinar, approximately it weighs 4 grams, and euro, approximately it weighs about 7 grams. Now we have to make our model to predict the currency of the coin from these weights. Okay, that is, if the rupee is if you're giving 3 grams, then the machine has to identify it is a rupee. Okay, here the weight becomes the feature and the currency becomes the label. So in supervised learning, label is very important here. So when you feed this data to the machine learning model, which feature is associated with which label? For example, it will learn that a coin is of 3 grams. It will identify it is a 1 rupee coin. So hence, supervised learning will be the main thing here. So hence it is a supervised learning. So we can using this labeled data, we can train the model. So on the basis of weight, your model will understand and predict that it is a 1 rupee coin. So if we are giving a 4-gram coin, okay, no need a label or something. So the machine has to identify that it is a dinar, 1 dinar. Okay, like that we have to train the machine. Now let's see another example. So here there is an apple, red apple. Okay, some sort of red apples is being given, 8 apples being given. So the machine is being trained automatically. So if you are giving the first apple, we are making it as an apple. We are making the machine to identify it as an apple. Then the algorithm will predict it is an apple. The processing continues for all the 8 apples. Suppose we are feeding a green apple. Okay, in the all the experiences is now being trained in the machine. And suppose if you are giving a green apple, the machine has to identify that it is an apple. So by looking the shape of the apple, now our machine has to identify that it is a green apple. So it must be an apple. So in that way, we have to train our machine, train our model. And in the next example, this is an thing for again a supervised model. So here we are giving a set of duck images. So some 4 duck images, 3 duck images are there, and 3 non-duck images are there. So here duck images, the machine is being trained automatically that this is a duck image, and some other animals except duck is being given as the input, and it must identify that it is not a duck. So from the predefined data set, the machine, if you are giving another form of duck image, so from the predefined knowledge, the machine now has to identify that it is a duck. So here, this is a quite a very bit interesting one. So there are 6 images which is being clustered here. 3 duck images are there and 3 non-duck images are there. And in the training phase, we are giving some sort of duck and not a duck images. It is a predefined data set. Then in the testing phase, if you are giving another form of duck image, which is not in the predefined data set, now also our machine has to identify that it is a duck. Okay. So like that way, we have to train our machines. Now this is an example for the supervised learning where the supervised learning can be applied in our real life. Weather forecasting. So here from the already given data, now our system has to identify the weather for the next few days, next 1 or 2 weeks. The machine has to identify what type of weather, humidity, temperature, etc. So from the experiences, it will learn that what is the temperature tomorrow or day after tomorrow. And the fingerprint also. So here we are giving a set of fingerprint images which is being already predefined. Now if you are giving a fingerprint. So from the past experiences, the machine will now identify, the machine has to identify whether the fingerprint matches or it does not match. Then in the healthcare, to identify a disease or not a disease, like that. Then in retail shopping, so this comes for the gold marketing also. So here, from the past days or from the past weeks, what is the rate of the particular gold or any gold item or any vegetables, maybe anything, retail, whatever maybe the retail things. So the machine will learn and what is the price tomorrow or day after tomorrow or the next few weeks, etc. So the machine has to, we have to design in that way, the machine has to learn from past experiences. And here the classification, how can we classify a supervised learning? So it can be made into 2 categories of algorithms. One is classification and the next one is regression. So the classification is either this or that. We can make multiple classifications, but for the basic use, we can make this or that. Either red or blue or disease or no disease, etc. Then in regression, so what is the output variable and maybe a dollar or weight. So a regression problem is when the output variable is a real value. So all these are real values. We are monitoring some patients. We are identifying whether the particular patient has a disease or not a disease. From it matches to the already patient record, and from that the machine can identify whether the person has got a disease or from the data, the blood group, etc., the WBC count, hemoglobin count. So from any type of the data, health data, the machine now has to identify whether the person is suffering from a disease or he is not suffering from a disease. And we have learned supervised learning till now, and what are the advantages of supervised learning? So this supervised learning is actually a teacher-student concept. The teacher will monitor the student always in the class, in writing exams, then in results. The supervised learning also follows the same concept. So it always monitors the mission. So it allows collecting data and produce data output from the previous experiences. It also learns from experiences, and it allows collecting data and produce data output from the previous experiences. It also helps to optimize performance criteria with the help of experience. So any algorithm it is, we have to uh, remember those three things, that is set of tasks, performance, and the evaluation. So this supervised learning can be used in majority of the research, and it helps to solve various types of real world computation. We also see some disadvantages with supervised learning. So it requires more, it takes more time in training the data. And what is the big disadvantage here is it cannot take big data. Big amount of data is not, it may not be possible with the supervised learning. So classifying big data will be is a challenging task in supervised learning, and for training itself it requires lot of computation time. So it requires more time. So for testing, when compared to testing, for training alone, the system has to be it takes more time for computation alone. Then what is unsupervised learning? Now let's see into this category, unsupervised learning. So here there is no label. So without labeled responses, the machine has to identify, classify, cluster any data set. If the data set we are providing, it is an input to the algorithm or any type of system. Now the machine has to identify, cluster, and classify those three things. And mathematically, unsupervised learning only have input data X, and there is no corresponding output variable. So the goal of unsupervised learning is to model the underlying structure or distribution of data in order to learn more about the data. So in supervised learning, there are many differences between supervised learning and unsupervised learning. In unsupervised learning approach, the data instances of a training data set do not have to be an expected output associated with them. So we can make references in that way. Instead, the unsupervised learning algorithm detects patterns based on any characteristics based on input data. So an example is clustering here. We could make clustering as the unsupervised learning. So if you are providing a set of images, from that it clusters first, it builds a group first, and from that group it classifies what it is. So this is unsupervised learning. Now here we can see the same diagram. So we are giving some three group of fruits here, apple, fruit, banana, and some other fruit. So here the similar data instances are grouped together. So we can see apple is being grouped together, and banana is being grouped together. So in order to identify that one, it is being grouped together. So this is the unsupervised algorithm. So here the input raw data is being given as the input to the algorithm. We are designing that model. So that algorithm is the model which is being designed, and the machine will now cluster based on the input. Okay. So all apples are being clustered together. Like that way, the fruits are being clustered together. And now let's take the duck images as the another example. So here the algorithm, we are not giving the label here. It is an unlabeled data again, and based on the characteristics, it groups the picture into three different clusters. So here the duck images, then some other image, okay, and the cartoon image, the cat image, and the image which is not a duck. So here it does not identify whether it is a duck or not. It just classifies first, it just clusters first, and from that it learns what has to be done next. And we could see another example here. Suppose we are attending a wedding, okay, a strange person wedding or some other friend's wedding, where majority of the people are not known to us. It is an unknown group, okay, except for a one or two we may knew. Okay, other persons, if we are unknown, if we are strangers to the wedding alone, so by looking at the persons, we automatically classify them. We automatically classify the persons. Okay, like we may build how many maids are attending this function, how many children are attending this function, okay, what type of dresses they are wearing, and how many females are attending this function, how many are old age group persons. Okay, like this, our brain automatically classifies it. Actually, this is the unsupervised learning. So we are actually new to the wedding. We may be able to, our brain automatically classifies them. Okay, like whether they are belonging to the bride side or groom side, or whether both the side, or like us, not bride side or groom side, just attending a function like this one. So like this, our brain automatically clusters them. Okay, people under 10 years of age, or persons under 50 years of age, or bright side, or what type of dresses they are wearing, and what colors of dresses they are wearing, and what type of food is being served. Like that, our brain automatically classifies it. So this is actually the unsupervised learning. So making clusters with no labeled data. Okay, actually we do not know them, but we are able to classify them. So this is the unsupervised learning. And this is the next type of learning, the reinforcement learning. So what it is it just learns by mistakes. Okay, it is by nature. Humans learn by mistake. So here it is a type of machine learning technique that enables an agent to learn in an interactive environment by trial and error using feedback from its own actions and experiences. So here we are seeing an image there. There is a rat and there is a cheese revolve. So here if the rat wants to eat the cheese, it searches the cheese where it is located. So it initially tries to find the path where the cheese is being located. So if it goes in the wrong way, it then finds, it learns by mistake that it is the wrong way, and then it identifies the new path. Finally, it gets the cheese. Likewise, the machine, so if it is wrong, from the mistake, it learns that it is wrong, and the machine should not go in that way, and it goes in the another way. It is a trial and error. Just trying, and if an error occurs, not going to that path. So this example is this diagram shows better than that one. So the rat and the cheese. So it is a trial and error, going by way, and if the way is not correct, it tries the other way. Likewise, if we are feeding an input and we are modeling, developing a model. So if we are not getting the correct output, it does not try in that way. So the machine has to be tried in some other way. So this is actually reinforcement learning. And what is the technique here? So here we are seeing a predictive class from what is classification, clustering, and regression. So classification, it predicts class from observation. So here, like duck and non-duck images. So it just classifies, okay, whether it is a duck or it is not a duck. And clustering is, it groups the observations into some meaningful groups. So here, it does not identify that this is wrong, but it puts into some other group. And finally, it identifies whether it is right or wrong. Then regression is, it predicts values from observations. So likewise, we are giving some value and it predicts some value from the observations. Like what is classifications? We are categorized. The best example is an email. So whether it is a spam or it is not a spam, like whether it is not a, whether the person has a disease or it is non-disease, or pass or fail. Like this way, we could classify it. Okay, either this or that, like pass or fail. None other category than that one. So classification is process of categorizing a given set of data into some classes. So here, a mail is the best example whether the mail is a spam or it is not spam. Then clustering. So here it does not say whether this or that. It just clusters. Okay. So grouping a set of objects in such a way that the objects in the same group are more similar to each other. The objects may not be predefined. So it is not a predefined data. So some examples are men's watch, men's shirt, women watch, and women's shirt. So these category of data can be clustered like men, okay, men objects or women objects, or shirt, shirt or watch. So like this it can be categorized. So it can be clustered into many groups. So here I put two groups. One is watch. Watch can be a men watch or a women watch. Shirt, it can be a men's shirt or a women's shirt. So like this it can be clustered into two groups. So this multiple, we can cluster this into a multiple way. Okay, men's watch, men's shirt, t-shirt, or a normal shirt. So like that way, it could be clustered like multiple more. And regression. So it is a supervised learning technique which helps in finding correlation between variables and enables us to predict the continuous output variable based on one or more predictor values. So one thing I would like to tell here is, so this reinforcement learning, it learns by mistake. So we have to design our machine in order to learn from mistakes. So do we need mathematics as the tool here? Okay, do we need mathematics as a tool? So one of the things is, do we need mathematics as the tool here? So is it necessary to learn mathematics for machine learning? Yes, it is very, very necessary to learn mathematics for machine learning. So as many other tools like why we want to learn mathematics. So we need to, the main thing here is to, we need to identify the algorithm for, we need to identify the right algorithm for any classification or any model we are going to develop. So we need to identify the number of features and then parameters. We need to identify the parameters. Then we need to calculate the accuracy. We need to counter the accuracy also. It is not only defining the model, it is not only training the model, it is not only the machine learns from experiences, but we need to consider the accuracy also. For any type of medical applications, accuracy is the must here. Accuracy is the main thing. So here, for any type of modeling or any type of algorithm being designed for a machine learning one, accuracy should be counted here. So even though lots of computation or lots of training needed for developing a machine model, accuracy to be main thing. Accuracy should be considered first, for especially for medical applications. For that, number of parameters are necessary. Okay, it is not only accuracy. We need to take the number of parameters. We can use many large number of parameters, especially for the medical one. So it is not with one parameter we cannot judge a disease. With one feature we cannot judge a disease. So though it is a very sensitive thing, we can use many number of features, many number of parameters can be chosen here. And it is not only the parameters or the number of features, we also parameter settings also we must take care of. So like whether the machine will be able to work continuously, okay, or whether the machine will be able to produce very good results, whether the machine will be able to get accurate results. So whether it identifies underfitting or overfitting. So the machine also identifies whether the data provided, what type of data being provided. So it identifies underfitting or overfitting. So here, these things are to be taken here. So for that, we need mathematics as the main tool. So with mathematics, we could design a very good model here. Now, where the mathematics can be used? What type of mathematics can be used for machine learning, for developing a machine learning? So we have to make the machine as our friend. We have to model the machine as our friend. So for that, we need mathematics as the extra tool here. Usually we can use probability at statistics. So majority of the machine learning algorithm uses linear algebra, probability and statistics. So here statistics, what type of statistics tool it requires? Probability. So here before designing a model, the researcher or the expert has to identify what type of mathematic technique has to be used, what type of things to be used. So if you are going to classify a design, if you are going to evaluate a performance like cricket score or any other comparing one batsman with other batsman or any other thing like this one, the researcher has to identify what type of tool to be used for which application. So if it is clearly known in the initial stage, then the machine can be made as a friend here. So if this is known at the initial stage, if we clearly study what type of tool to be used for which design and what type of results should be evaluated, what type of results should be obtained. So if this tool is known to us, if this thing is known to us, then we can make the machine to make us a friend. This will be a new friend to us also. As this is the thing we need, and again we need to identify what type of machine learning should be used for it, like supervised learning or unsupervised learning or reinforcement learning. So we should not take care of money, we should not take care of the time here. So even though if you are taking more time, the model must be an accurate one. Okay, the researchers will always say computation time. So this takes computation time, more of computation time. So it could be made better. The time could be reduced. So by applying some other tools or anything, the computation time could be reduced here. But the result should be an accurate one. So if we go for reinforcement learning, so this also be taken into care. So this type of machine will always learn from mistakes. So if there are more mistakes, then the model will become a fault one. The model will be a faulty one. So if the machine has developed more number of mistakes, so this type of machine learning learns from mistakes. So if the mistakes are identified more, then this model will be a wrong one. So this will not go into a further one. So instead of that one, we could go for unsupervised learning or supervised learning. So if we are in the initial stage, we can go for unsupervised learning, develop a model from that, then from that we can make into an unsupervised learning. So we could use clustering technique also for clustering a group of data, or we can use a classification technique for classifying some data. So any other approach we are using, we should be able to produce a result. So if it is a sensitive data or a sensitive applications, then the machine should be modeled in that way. Any type of tool which is being used, any feature extraction or feature classification or image classification, what may be the application, but we should be able to get some results. May not at the initial stage may not be an accurate one, but we are if we are going for a medical application or some other which is very sensitive, then our model should be developed in that way. Uh, sure, shall I end the session? Shall I close the session, sir?